Hello, my name is Jamie, and this is the next installment in the Dollhouse series. In the previous video, we talked about the stone patterns, the pseudo-random stones. In this video, we're going to be talking about casement windows and lattice windows. Get started. Casement windows consist of a square frame. Inside of it is a flat pane, and then what we do is we cut out windows for the rows and columns. And one important concept when this is printed is, so in the gist we have a wall. This is a room, we have a wall, we select the wall, we're going to indicate how many windows we want to print out, in this case 4. We're going to make an outline of the window shape and cut through the wall of that, just straight cut through. Then when we set these guys up, we're going to define out what the frame is, we're going to make a flat plane, and I don't think it's with this one, I think it's with the last one. So we're going to make a flat plane, and then we're going to cut out our tile shape in a grid pattern. And then what's left, this framing bit, is what ends up becoming the actual internal guts of the window. Now, when this was printed, 3D printer concept we're going to talk about is bridging. When this was printed, the rows came up. All this is doing is there's no support materials when this window was printed. Basically, it just connected between here and here and made the bridge. And I can show that better if we come over to here. So this is all 3DP tutorial. So these count as overhangs. This counts as a bridge, and these are overhangs again. And a good one to show bridging is this particular model. And I actually have a printed copy of this. This model shows bridging very well. And all bridging is basically you have 2 anchor points. You have a point here and a point here. The print head just goes all the way across. So when this was printed, there was no support materials at all. And you can see for the farther distances is when this starts falling apart effectively. So there's less material in here, and you see the strands are separated. So when this printed, it basically started drooping. But for distances that are smaller, the bridging worked quite well. And so when this model, let me get back over here. When this model was printed, all this is doing is the bridging concept. And so there's no support materials in this window at all. All right, let me go back over, down, and make sure we're back on our desktop. Okay. Let's go to, oh, I know what I wanted to show. Here I have the model already loaded into the Cura slicer. I already have this model sliced. And we can come down to about layer 500 or so. And we can see what it actually did when it made the slice. So here we have our bridge points, and when we go to the next layer, it just runs the print head straight across. Get this situated. That's a little better. Okay, and so that's that whole concept right there. So in regards to printing, again, I've already said this a couple times, but there was no support materials when we were printing off the casement windows. Let's talk about code. I'm going to grab my code example for generating casement windows. We're going to go back to our previous example from the last video, which was for making stones. And I'm going to add this to the code. And I'll link to this example code as a GitHub gist in the video description. So we're going to link this code in here. The new requirement is going to be the series. We'll import that from CadQuery helper. This is a library that I wrote. Import series. And then we need to modify our wall in order to add casement windows. And I'll end up skeefing some code from the dollhouse. So we'll copy this bit here. We have our blueprint for a building. After we've made it, we're going to modify, in this case, not the ground floor, but we're going to modify the second floor to have windows. And after we've added the window code, we'll have to call the make method. I've tried writing this demo up once before, and I had basically a bug. See how this goes. Instead of first floor, we're going to declare second floor. And I'm going to modify this code a little bit. And we'll go to index 1, and we'll call this second. And so second floor, we'll declare our window count. We'll declare our window height, declare our window length, and then we're going to define making our custom windows. For the moment, I'm going to comment that code out because that can be cause some demo strains for me the last time. All right, and then we're going to put in our make code against the second floor. Just run this and see what happens. Good. Okay. And so we have on our second floor, and did it do it in two places? Yeah, okay, that's where it gets a little bit wacky. So I gotta change my window walls for the second floor. What we have is we have our declaration of our arches are on two of the walls. So where we make door walls, there we go. Two of these have arches by the time they're made. There, these two. Up here, we also have our window walls. Two of these are hitting on each other. What I think I need to do is change this one probably to a false. So we got true, true. Let's try changing that. That's probably better. By the time I apply this one, the custom windows, some weirdness can happen if you've got windows and a door on the same layer. All right, so let's try adding our casement windows. Bam, sweet. And I'll show you what I mean where things can get weird. If I have window walls on this wall and window walls on this wall, they're going to conflict a little bit. And by the time you add the casement window, so there's our arch, but now it's filled in, right? So there's basically an order of operations happening. Feed in a wall, cut in the windows, and I think this is all solid, isn't it? And it's basically overlapping the other cut wall where it's trying to cut the door out. And it got weird. That's probably some internal logic bug. Because in theory, you should be able to have windows on a wall that also has a door, but at the moment, that's a bug with the code. All right, let's fix that. Instead, we have this wall, which has the stone pattern on it, and then it has the casement windows. And with these parameters, we could change what the window looks like. So instead of 4, now we have 3. We can make the width of this 40. Now they're kind of elongated, and we can also increase the height. Let's say 60. Bam. And in theory, we can also add it on the first floor as well. I don't know if I'll mess with that today to give an example, but it shouldn't be too hard. Am I customizing this guy at all? So window walls, first floor. What am I doing to kill that? Oh, that's what I'm doing. Oh, okay. Where do I have it? Let's just remove that. There's our window wall. And then we can do a similar pattern here. And what this will show is that they can be, we'll end up changing this out to the lattice. One will be casement windows and one will be lattice. We'll switch it out that way. All right, let's just do two. And we'll go back to 40. And we'll go back to, say, 30 or so. So we'll do two windows. And let's fix that. Let's see what happens. Bam. Okay. Yes, they can be set in isolation of each other. All right. Now let's look at the casement window code itself, and we're going to kind of simplify what we're returning. Let's do basically comment out some stuff before I get too far. So we make a cutout series. Let's show the individual cutout first. The first thing we do is we make a cutout. And see, here's the cutout in isolation. So this is a singular window. And what this is the basically the hole punch. So we have a wall. We're going to use this in order to cut off from the wall in order to make an empty spacing. Then we call in this code from CadQuery helper series to make a row based on the window count, how many windows we want. We're going to place them next to each other side by side. And let's show the series. There we go. And these are with very little padding. There's like a 1 millimeter, maybe a little bit less padding in between each of these. Based on the window count, so first we make our cutout, then we're going to make a series of these things based on the count we passed in, and then we're going to cut those out of the wall. Let's do that. Here's our wall. We're going to remove our cut, and let's return back the passed in wall. And you can see what that looks like. Bam. There's our wall with the cutout removed. All right, next thing we're going to do is we're going to make our frame. And that is the square box around the window. Let's show a frame. Bam. This is back to the singular window method because we're going to make another series to fill in those punch outs. Here's our frame. Then we're going to make our grill. And that is here. And the specifics of that is, let's just show grill. And I can talk about it in more in depth once we're looking at it. Okay. So we're going to make a grill. And we're going to pass in our window length, the overall depth, the width of the window. We're going to pass in our window height. In this case, I'm hard coding the depth. We're going to pass in the number of rows we want, which is from top to bottom, and then the number of columns we want from left to right. And we can actually expand that. So if we make this 3, get a different grid layout. There we go. And then Grill width, we're hard coding, which is just the width of the grill itself, and then grill height is the height of the grill itself, and I'm hard coding that at the moment. We're going to combine those two. So for I window, we'll add our grill. And that's a complete casement window. And then we're going to add a series of these windows. That'll put them next to each other. There we go. There's our window with the grill and the frame. And then finally, on the wall, we have this operation. So one, we cut out our hole punch series. So let's just show that. And then we add the individual windows. There we go. I'll talk about the specifics of how we made the grill next. First thing is we're going to go to CQ Terrain and grab the code for making the grill, the casement framing. In this case, it's under Window. I have this code called grill. We're going to copy this, come over into our example code, grab this grill code, and places where we're calling window, so window grill, we'll call this code locally. We won't resolve it off of the CQ terrain import. So what is this doing? It's got a length, a width, a height, columns, rows, grill width, grill height, and then anything weird going into this? No, it should be pretty straightforward. Okay, so let's render that. And it broke. Oh. Order matters, apparently. Is that better? Let's see if I can get that to go. If I put it, yeah, it should be at the top, I would think. So if I have you here, what do you do? Grump at me. Well, I might have to reshoot this video. Where do you go? How do we fix this problem? Grill is rendered before assignment. Oh, that's why. Because the name spacing blows. So let's just make it grill custom. Yeah, becomes a reserved namespace. That's my problem. Let's try that again. Grid. It doesn't like grid. And so from here, let's import in grid. That's better. Okay. Hey, maybe I saved this section. All right. What are we doing? And the reason I'm covering this is so that we can go into specifics on how these are made. So we've got a pane, and let's just return back our pane. So instead of combine, we'll throw back our pane. There we go. This is the initial frame without the tiles removed yet. I'm going to change this a bit to here, when we draw the casement window, just return back the grill for now. We're going to call grill custom, assign it to a variable, and we're just going to return that straight. So all of this extra stuff, like returning the wall with the series cutouts and the whole deal, we're just going to ignore for the moment. There we go. There is our pane. Two panes, one for the upper floor, one for the lower floor. Next, we go to grab the tile width and the tile height. which are basically passed in at the time that we create our grill. Oh, no, it's not passed in. It's defined by the number of rows and columns you want. So we're deriving that off the length and width of the window. We're going to have that. We're going to make an individual tile. And let's show what the individual tile looks like. It won't be too fancy. That's what the individual tile looks like at the moment. We're going to create a grid of these tiles. There we go. This is the grid of our tiles. This is the cutout. So if we take the inverse of this, so if we apply our frame, instead of doing cut, let's do add. So if we take our pane and we add our tiles to it, and return back combine. Okay, there we go. So here's our frame, our pane in the middle of this thing. Here's the tiles, and you'll see that there's some spacers in between here. That's providing room for the width and the height of the frame itself. So when we create the grid, we set dimensions to the grid that are slightly bigger than the tile width. So here's the width of the tile plus the grill width, and the height of the tile plus the grill height. No, grill width again, it's square. Okay, I dig it. Do I even use grill height? Are you used? Yeah, it is. Oh, interesting. Okay, I'm not gonna fight with that for right now. Anyways, so to get this to be our actual frame, casement frame, the grill, we're going to cut out these tiles from our pane. I'll do a cut, apply that, and there is our one grill. That's how we got here. And so I'm going to take this guy, and instead of return back grill, we'll return back our width, and bam, there we go. And that's pretty much everything I want to demo for the casement windows. The next thing we'll move on to is the lattice windows. So let me get set up for that, and we'll talk about that next. First thing is the only real difference between the casement windows and the lattice windows is the grill pattern. And this is the code explicitly out of CadQuery for the lattice pattern, but we're going to re-implement it in the demo. So let's grab the code out of the Dollhouse for lattice windows. We'll come back over to here, and I'm going to add in that code. So this is the code for lattice windows. We're going to go down to where we're assigning the lattice windows. So on the first floor, because why not, we'll, instead of doing casement windows, we'll do lattice. So the name of the custom method for making the windows. Let's run that. There we go. And here's our lattice window. And so what are we doing here? Well, we're making a window cutout, which we've seen before. That's just the punch hole. We're making a series of those, so in this case 2, and we're going to remove those from the wall. We're making our eye window, which is going to contain of a window frame and this lattice code, which is called window.lattice. And that is coming out of CadQuery. And that code looks like that. Okay. Let's yoink that real quick. See if we can still get this to work. What is that doing? Are you doing the frame? Maybe, maybe not. Doesn't look like it. Okay. And so here, where we're assigning lattice, we'll say lattice custom. So you can get all the code at once. And so call window lattice, we'll call lattice custom and assign it to the variable lattice. Something like that. Let's see if that still works. Nope.
Because it wants to import a math. It's doing stuff like math.floor and math.hypotenuse. Let's grab import math. We'll run it. Okay. So now we're in a better position to talk about that. All right, so we're going to make our lattice, which we'll go into in the next little bit. And then we're going to make a window series with the frame and then the lattice pattern, and we're going to apply it to the wall. So let me skip to the actual printed copy. Here we have our lattice windows. In this case, for this printed example, we have 3 of them. And what this is relying on is, unlike the casement windows, which was using bridging, this one is relying on the ability to print overhangs. And so this is exactly at 45 degrees. And what this is basically we're taking a square tile, we're rotating it 45 degrees, and then the same way that we made the casement frame by making a pane and then cutting out the tiles, same dealy. The only difference is because we have this little bit of partial tiles, right, where we're cutting out, in order to make up for any size window, in order to make the pane or some aspect of this, what I'm grabbing is the hypotenuse of the pane, of the width and length. So I'm grabbing the diagonal, the longest angle I can, the longest length I can grab out of this, because the diagonal will be longer than the width and the height of the window. I'm grabbing the longest angle by grabbing the hypotenuse between the 2 farthest points, and basically rotating that, applying the grid against the hypotenuse. So making a, and we'll see it when we go back into the code. I'm making the pane bigger, or at least the grid pattern. I'm making the tile pattern bigger than the window itself in order to do partial tiles. So I can rotate it 45 degrees and still have it cover all the spacing. And let's go back to the share. The main thing that this requires is hinges on for theory wise is when printing overhangs, and this is on all 3DP. When printing these guys, these are just within the 45-degree angle mark. So there isn't support layers when printing the lattice windows either. And the reason why that works is because it's relying on that 45-degree rule. And in the physical printed copy, you can see how well it did with that, which isn't too bad. All right, so let's look at the code for the actual lattice pattern. So you see the first thing here is we're grabbing the determine longest distance between points. We're grabbing the hypotenuse. We're going to determine our columns for the grid, the tile pattern, off the hypotenuse. And we're going to determine our rows off the grid for the hypotenuse, which is going to have some slush. There's going to be some extras in that. But it's good enough to make sure that we cover the whole window. Because if I just grab, the width and length of this thing and then turned it 45 degrees, that wouldn't cover the whole thing, right? The whole area. Then we're going to make our pane. So let's copy this, and we'll show what that looks like. Bam. So there is our pane, and we can change this out. So instead of showing, we'll show the lattice pattern here. So we get just the window. There we go. So there's our pane in isolation. Then we're going to make our tile. So let's return back to tile. And in this case, the tile size has a set, it's assuming square tiles. So you can set the tile size, which is basically the pattern. They're smaller than like the casement windows. So there's a tile. In this case, it's defaulting it to 4. And we can probably grow that a bit. Let's make it 6. And we'll see if that grows at all. Yeah, a little bit. What if we make it 16? Nope, that did nothing. Yeah, let's go back to 6. So when you're declaring your lattice for the lattice window, There it is. Let's make it 10. So the tile size up here is the default constructor for tile sizes and presented. As soon as I added a tile size, we get a larger tile size when we go to instance this guy. So because it's being declared down here on the constructor for lattice windows, when we come down to actually declare it, because we're declaring the hard-coded tile size, that's what it's using. All right, so we make our tile, then we're going to make our array of tiles. Make sure I get that right, and we'll run it. Okay, there is our array of tiles, our grid of tiles, right? And so this guy is going to end up getting, we cut our tiles from the pane. Instead, let's do add so you can see what I'm talking about. Bam. And so here we see the overlap, but this is where we're getting to where it's not too much slush, right? It's not too much overlap, because what I want is I want to make sure that this pattern covers the entire pane and basically guarantee that. So regardless of the window size, whether it's 40 by 80, I want to guarantee that the pattern will always fit the window. And so that's why we're doing the hypotenuse and then turning it n number of degrees in order to fit this. So we have these corners, these little corner pieces that are useless, right? But that's it. The rest of this pattern is actually used in order to make the frame. And so if I do a cut, and return back our pane, let's try that. That should be better. There we go. There's our actual cutout. And we got a little bit of slush, but that's okay. And if I go back here and change this from tile size of 10 to a file size of 6, we get that pattern. There we go. And you can change that to any size you want, so we could even do as big as 16. That's more on the aesthetic, so more so what you're looking for. Okay, so here we're returning back that. Let's change this to I window and you get a sense of what's going on here. There we go. And so by the time we add our framing, it's cutting out the corner bit, right? So the corner bit's still there, but that's not visible. So let's set this back to 10. Yeah, okay. And the frame is what's eating up the little bit. So the frame, the little corner bits there, that's why I've never seen that before where it had the extra corner bit. And so far I've just gotten lucky, I suppose. Okay. So that is effectively the lattice, and you can assign variable degrees to this thing. So in this case, I'm using 40 degrees for the turn. 45. You can lower or lessen that. Uh, I know 45 prints. I'm not sure what it would do. I haven't tried printing it at other angles, but you can play with that. So you can do, if you didn't want to turn it at all, you just get a grill, right? Which is similar to the casement. And the main difference, in order to cover the area, the main difference between the casement is it was making the tile pattern exactly according to the width and height of the window. In this case, we're making the lattice, it's going across the hypotenuse. All right, we'll set that 45. Let's see if we can show this working. And we'll go back here. So on grill custom, we're returning back our combined. We're doing our cut, and here we're returning back the window. Pretty sure. This guy. Yeah, we're returning back the wall itself. Bam. All right. And just to prove a point, if we go back down to where the window's declared, you can change the properties of that. So if you wanted, say 5, yep, and here it's overshooting the wall length that's set to 4. Well, and so the 5 would work, but we'd lower the overall length. So instead of 38, we can say 28, which should make up. Bam, there we go. And there are our lattice windows, custom saved. All right, so that's probably getting close to doing it for this video. Let me double check, make sure I don't have any other notes. So there's our notes for the window. There's what it looks into, and the next one we're gonna start talking about the roof. Okay, good. Dig it. Good enough. Thanks for watching.